All right, let's get started. So first order of business is that I was sent a text. Did y'all get the text about the drill today?
Yes.
Okay, so I don't know what that means. I guess at 10 or so, I don't know if we're gonna hear something or if there's gonna be a text that goes out to everyone that we're supposed to.
I know other buildings have the drills and nothing really happened.
But you had to get up and go?
No, I know no one.
No one did anything?
The drill was supposed to happen, but I guess it didn't happen.
Okay, well, let's see what happens. Hopefully they won't make us walk out of the building. I remember I was in graduate school and I was sitting there in a class and the fire alarm went off and the professor, we all started to stand up and he's like, no, sit down, we're not leaving. So, but I don't want to do that. If they tell us to leave, we're going to leave, okay? All right, with that said, we might lose 15, 20, maybe even 30 minutes. I don't know how long the drill will take. So let's get down to, we need to finish talking about the material that you need in order to complete the review. So I sent out the review. Yes, everyone got that? And you should have had, some issues maybe with number 12, 13, 14, 15. Everything up to that point was stuff we had covered. So let's try and just go through the material that we need to get those last few out of the way. Were there any issues on any of the first 11 problems? Did anyone have anything? Okay, which one?
10.
Number 10? Okay, so we'll talk about that in a little bit. I just wanted to know how it went. Okay, let me jump to this page here. Whoa. Way off. So if you went over the review, you'll probably agree that the review is pretty much everything you saw, we've seen before, right? Like no surprises there? Okay. All right. Okay, so percents, here we are. This is where we were. We had done these problems where I asked you to convert a sentence into an equation and then to solve that equation. All right? So now let's look at some word problems. And the thing about these word problems is that, well, they're word problems, right? And everybody seems to have trouble once the math problems turn into word problems. So let's see how we do with this first one. It says 30% of all students at Northwest Vista College transfer to UTSA. I'm going to stop moving it. Come on, right there. All right, so 30% of all students at Northwest Vista transfer to UTSA. Of these transfer students, 12% are going to biology. If there are 15,435 students at Northwest Vista, how many of them will transfer to UTSA and major in biology? All right, so I'm real big on pictures. I like to draw pictures. So let's say that these are all the students at Northwest Vista College, right? There they are. And how many are there? 15,435. That's how many students are here. Now, of these students, how many of them are going to transfer over to UTSA? 30%, right? So we need to figure out what is 30% of 15,435. So that's the word sentence, right? That we can now convert into an equation. So that's why we did the previous problems where we converted from the sentence to the equation. Because if we can understand that 30% of these students are going there, then we want 30% of this, right? So what is this converted to an equation? So remember, is means what? Equals, right? What is what we're solving for, right? So we can call that x. X is 30%, which I'll write as a decimal, 0.30, and then of is multiplication, right? I'm going a little fast because of the drill. I'm worried that we're going to run out of time. So now we just do that on our calculator. And let's see what we get. So 0.3 times 15,435 would give us 4630.5. That's what I'm getting. So we have, of the 15,435 students, right, 4,630.5 of them are going to UTSA, right? So we have like 0.5 of a person. That's okay because some of you are half people, right? No? I mean, it's just, this is an estimate, right? It's an estimate. So we could say, 4,630 or 4,631, doesn't matter. Okay? So that's how many have come to UTSA. Now, the next part of the problem says, of these transfer students, so of these people that came over, how many are going to biology? 12%, right? So you could say, of the students that came over here, here's the group of students that came from Northwest Vista, right? These came from NBC. Only, what, 12% of these are going to go into biology? So how would we write that out in a word sentence? What do we need to do? We need to find,
X.
So what is 12%? What is 12% of this, right? 4,630. I'll keep it as 0.5. And now we convert that. We'll say X equals 0.12 times 4,630.5. And we just do that multiplication. Okay, so times 0.12, and we get approximately 555. So I use this little squiggly equal sign. Okay, that means approximately. And it's not something I just made up. I mean, we use this in mathematics, we use this symbol. Okay, so if you said 556, I'd be okay with that too, all right? Does that make sense? So this problem required that we solve two equations. Now there are some shorter ways you could do this. Like some of you may have got to the answer without writing out those sentences. And I'm okay with that as long as you're showing your work. Questions? Look at number 8. 30% of all students at Northwest Vista transfer to UTSA. Of these transfer students, 12% are going to major in biology. What percent of Northwest Vista students are going to UTSA and major in biology? Is that the same question?
Yes.
It's kind of the same question, but it's not the same question. Because in the original number 8 or number 7, we were told how many students were at Northwest Vista College, right? Here, we are not given how many we start with. We're asked to find what percent of Northwest Vista students are actually going to wind up at UTSA in biology. What percent? So we can answer that question kind of two different ways. Does anyone have a suggestion of how we could do it using what we just did? Do we know how many students wound up at UTSA in biology? Yes? And it's the same percentages, right? 12% and 30%, right? So this is the same problem. It's just without numbers. We know how many students wound up at UTSA in biology, and we know how many students we started with at Northwest Vista, right? So what percentage do we have? How do we do that? Remember, it's the part out of the whole. That's what we said about percent last time. It's the part divided by the whole, right? The whole thing. So what part of our students wound up at UTSA in biology? 555. Out of how many students did we start with at Northwest Vista? 15,435. Look, I mean, this is kind of like, you're looking at me like I'm crazy. So this is kind of like saying, this is how many people had iPhones, right? Out of the total population. So what percent had iPhones? You just take that number divided by that. So that's what we're doing here. So what is that on our calculators? Take that 555, divide it by 15,435. I'm getting about 0.0359. It keeps going, right? I'm just going to round it. And on the test, I would say round to like 3 decimal places. All right? I didn't put that in the instructions for the test on Monday, but just round like 3 decimal places and we'll be okay. So if you wanted to make this 0.036, that would be good. Now, is that our answer? It's asking for what? What's the percent? So we just convert that to a percentage, and as a percentage, that is 3.6%. So what we're saying is that out of the total population at Northwest Vista College, we should expect 3.6% of the population to wind up at UTSA in biology. All right? Questions on those two?
So on the test, are they going to be almost worded just like that? It's similar so that we know we're going to use number 7's 555 to use as...
It would be worded similarly, yes.
Okay.
Yeah.
And we're going to be able to use our calculators?
Yes, you can use your calculator. So the instructions, I guess we can talk about the test right now then. The test is on Monday, right? I told you I won't be here. In fact, I won't be here Friday either, so just FYI. And tomorrow I'll be in my office, but not till noon. So I've got a lot of things going on the next few days. Monday, there will be a proctor. His name is Gilly. He's going to come in here. He's going to put you all in rows and have you all sit. You're going to take everything off your desk except your calculator, pencils, erasers. Everything else is done on the exam, so you don't need paper. You have to put your phones away. You have to put everything in bags on the floor. Nothing on the tables. And then he'll start the test. Hopefully he'll project up here the time that you have remaining, because that clock is right. I think it is right. Yeah. So he'll put how much time is left on the test. You have the entire class period. It's the first exam, and I think it's the easiest of all the exams. I just want to kind of let's just get a grade in. Let's just get one test done. All right. So I don't think you'll need the whole time, but everyone's different. So during the test, the instructions to him are this. If you do not, remember I told you might be able to use like a little formula sheet, like a cheat sheet that you make up? And I talked about how we would do that. It's a little hard with a proctor to do this, but what I've done is I've said that that my students may have a cheat sheet that you've created. That cheat sheet can't have any worked out problems. It can just have steps and procedures. You can say, hey, remember to do this. You can write yourself anything you want on it. Just don't work any problems out. Don't just take the review and work it out. Okay, that won't be acceptable. So if you do that, if you create a cheat sheet, there's an 8-point penalty. So the highest grade you can get is a 92. If you don't use a cheat sheet, then you can get 100. All right? That's the way I'm going to do it. It's just easiest for him. So you need to make that decision. Do you want the cheat sheet or not? So what he's going to do is he's going to pass out the test, and then after a minute or two, he's going to come by, and whoever has a cheat sheet, whoever's using a cheat sheet for the test, he's going to put a circle around your name on the test. And that way I know who had the cheat sheets and who didn't. All right? So if during the test, let's say you come in and you're like, I don't want to use a cheat sheet, right? And then during the test you change your mind, right? Then you take out a cheat sheet, that's going to be cheating, right? You need to make the decision in the beginning, right? You're either going to use it or you're not, all right? That sound okay? I hate not being here, but that's the way we're going to do it. And then, what else? You have the whole time. Then you'll turn in the test. When you're done, you turn in the test. If you used a cheat sheet, you turn in your cheat sheet, and then you're free to leave. And then I'll see you on Wednesday. Okay? Any questions? That pretty clear? Cheat sheet, one 8.5 by 11 sheet of paper. You can write front and back. If you want to use a little index card, that's fine. But this is as big as you can go, but you can write on the front and back. If you want to type it up, type it up. I don't care. All right? Okay. Let's move on. All right, in a Gallup poll of 976 students, 68 said they drink alcohol every day. Every day. And then it says, what is the percentage of respondents who said that they have a drink every day? Okay, that's... So what do we do here? Is this a complicated problem compared to the previous two? No? Just wants to know what percentage of adults say that they drink alcohol every day, right? Out of these people polled. So all we have to do here is what? 68. Divide 68 by 976. And that should give us our decimal answer, and then we'll convert to a percentage. 68 divided by 976. Done. This comes out to be about 0.0. If I said round to the nearest, this is actually going to round up to, if I say round the first 3 decimal places, then the calculator gave me this. So since this is a 6, I'm going to round this one up, but to round that one up makes it turn into a 10, so 0 and then carry the 1. So 7%? 7%. All right, good? All right, let's move on to proportions. Proportions. So proportions are some of my favorite things to kind of understand in this class because I think they're relevant. I think they're relevant. Let's see what you think. So let's see, does anyone have like a snack or a drink or something on their table with them? But does it have like, I'm looking for something that has like calorie information or something. Oh, there we go. Can we use that? All right, can I pick it up? Yeah. Is that all right? Okay. All right, so this is a McCafe. Oh, they actually make it and you can buy it in the store? Yeah. Okay. So this is a, some sort of coffee sort of thing? Okay. So this says that there are 260 calories in one serving. All right? That's what it says. 260 calories in one serving. Now, how many servings do you think are in this thing?
1.5.
It's actually, the serving is actually the bottle. So there's only one serving. But you have to be careful when you read bottles because if it says there's this many calories in one serving and then they tell you that the bottle is 4 servings, then what they're really saying is that there's this times 4 in here. All right, so I'm just going to use this because that's what you had. So there are 260 calories in one serving of that, right? So my question is, how many calories in 3.5 servings? That's the first question. I'll call that A. And my second question is, how many servings to get 1,000 calories. All right, so look, some of you can probably do these problems without having to think too hard or make it too mathy. That's not the point of this. The point is that I'm trying to force you to look at this from a mathematical perspective, all right? So what we're given here, this right here is kind of the big given information. Do y'all know what a calorie is, by the way? What is a calorie? You're shaking your head. What is a calorie?
So it's like if you want to eat like 300 calories per day or something, I think it's like what, part of fat or something?
Okay, so yeah, I mean, we've all heard of calories. We know when we eat things, it's calories, right? But did you raise your hand?
Oh yeah, I was gonna say the unit of energy.
It's a unit of energy. Do you know? Okay, so it's like a packet of energy. So energy is actually heat. Okay, heat is energy basically. Why are you You don't like them? What are you overthinking? Okay, so listen. 1 calorie is the amount of heat required to take one little box that's 1 centimeter by 1 centimeter by 1 centimeter of water. Okay, imagine that's water, okay? Let's say that water is 80 degrees. 80 degrees. 1 calorie is the amount of heat required to raise the temperature of that little block by 1 degree. So imagine taking a little block with water in it that's 80 degrees and putting a lighter under it, okay? When you raise it to 81 degrees, you have used 1 calorie of energy. Does that make sense? So, when our bodies are like machines, right? And we create heat. We all have a temperature at 80, whatever it is, 98.6, not 80, sorry, you're dead at that point. 98.6, right? So the heat we're generating is energy, right? I mean, we need energy in order to function, right? So we eat. So we have to consume a certain number of calories every day in order to function properly. For most people, I'm going off tangent, but we're about to have a drill, so that's why I can't get into this problem too deep. So do you all know how many calories, on average, like an adult needs per day? 2,000. I think a lot of things depends on, if you're male or female, if you're tall or short, but let's just go with 2,000, right? So that means that in order for your body to run properly, to work, it's like gas into your car, right? So if you need 2,000 calories, you are drinking that, you're going to be on your way to 2,000 calories, right? So then you eat something for lunch, right? So the whole idea is that you take in as much as you burn, right? What happens if you only take in 1,000 calories? Well, let's do it the other way first. What happens if you take in 3,000 calories that day? What happens to that extra 1,000? Your body says, okay. So way back when we were like running through the woods looking for food, right? Being attacked by animals and fighting for our lives, right? Scavenging for food. Our body said, look, if we ever get more food than we need to store it, right? Because what happens when we can't find food? So what happens when you consume 3,000 calories? Your body says, I'm going to put that in a little storage for later. And so it puts it into fat. That's what it does, right? And then you store, right? Or if you take in 1,000 calories, your body's like, I need more calories. Where do I go to get it? It goes to the fat, and it starts using that, right? Okay. But it's all heat, and it's all energy, right? So this drink is good, right? Yeah. It's good stuff, right? Okay. And there's a difference between eating if you eat 3,000 calories of butter versus 3,000 calories of vegetables, there are differences that has different impacts on your body. But this is like a general sort, I'm not a nutritionist up here, okay? I'm just trying to get us to understand what these are, how they're important to us. So let's say that we have 260 calories in that one drink. My first question is, how many calories are in 3.5 servings? So what would you do to do this first one? So one serving is 260 calories. How many calories are in 3.5 servings? Multiply by 3.5. Most people are going to be able to do that without much thought. And even though I agree with you, that will get you the answer, I want you to look at this from a slightly different perspective. Okay, so here's a perspective I want you to use. This right here is what we call an equivalence. What we're saying is there are 260 calories that is equal to one serving. I'm just going to say one serving. What would we call that? It's not a can, it's a bottle? Okay, bottle. All right. One bottle. Okay, so one bottle is this many calories. Okay, this is an equivalence relationship here. Now, anytime you ever have an equivalence relationship, this might be in a chemistry class or a biology class, if you have one quantity is somehow equal to another, then from that you can create what are called ratios or proportions. So this right here can be written in two different ways. One way is to write 260 calories divided by one bottle. And so imagine what I'm doing here is I'm taking this and I'm dividing this side by one bottle and this side by one bottle. Okay? So if I divide this side by one bottle, I get 1. And this side by one bottle, I get this side. So do you all agree that this is 1? This is the number 1. Yeah. Yes? Okay. But could I have done it the other way around? Could I have done this one, divide this side by this and this side by this? And it would be backwards. It would be one bottle over one bottle over 260 calories. I know you're sitting there going, why are we making this so complicated? All we had to do is multiply by 3.5. Just bear with me, all right? Equivalence relationship, from that you can create two different equivalent fractions. These are both equal to one another, and they're both equal to 1. We good? Now, why? Okay, we'll come over here. This first question, I'll come back to the second one. This first question says, how many calories are in this many servings, right? So we would like to know how many calories, right? So what I'm going to do is I'm going to put, I have X calories, right, is what I'm looking for. And the other part I have was servings, right? So I'm going to put on here 3.5 servings. So what I've done is I've created a proportion out of this, what I wanted divided by the number of servings I have, right? So this is really, servings is bottles, because we said a bottle is a serving, right? Okay, so I want to know what X is, yes? Okay, so now, how do you think I can get that?
I'm going to put equals 260 calories over one bottle. Line them up.
Okay, so think about it as a fraction. Okay, think about this as a fraction. What do I want my final answer? My final answer is this calories, right? So I'm going to multiply this by 1. And I have to choose which of these two I want to use. The first one? So what's your logic on the first one?
That's just how I've always set it up. Calories to calories, bottle to bottle, plus multiply divided. So that's what makes sense to me.
Okay.
You're kind of losing me with the other way, so maybe I just...
No. There's not an equals. That's why, because you're talking about cross multiplying, right? Cross multiplying, but I don't have an equal sign here. Do you see what I'm saying?
I'm just going to wait and see.
Okay. Let me do it this way. I think I'm going to confuse everyone too much that way. I feel like we're about to get a thing on our phones and it's bothering me because I don't know if I should keep going or just stop. I'm going to keep going. Okay, this is what we want, right? X calories over bottles. This proportion right here, let's use the equals because I think most people are going to want to do that cross multiply and we'll get in trouble if we don't. Okay, this should be there it is.
Hey, you called it.
Yeah. Okay, let's see if we get instructions. Hold on, let's just see if we get instructions. Are they supposed to? Here it is. No?
Did it send you an email or anything?
They said, the email I got said there's going to be a drill and that the faculty and staff will give you instructions. Okay. Has anyone done this in another building? No? Okay. You have, did everyone just walk out?
Well, it was like some people did and some people didn't, but no one really got it.
Oh, here it comes. No? No? Do y'all want to walk out?
Yeah.
Yeah, let's just walk out. Okay, I'll lock the door, but leave your personal stuff at your own risk. I feel like we're in high school again. I think y'all should go left, no? Steven, we can't go that way?
Obstructed. It's obstructed.
Okay.
Yeah.
Oh, okay. Just follow the masses, I guess.
And I was a drill coordinator. Just follow everyone.
God damn. Oh, thank goodness. Where are we supposed to go? Where we go? You want? How do you like it? They build upon each other. Examples are good. Examples in there, and they're good examples. And you can work. You have to go real slow with that class. You have to really take the time for each example. There's so many little things in there, right? Because I'm trying to remember the definition of a topological space. If you know it yet, it's a collection of sets contains the empty set. The
it contains the empty set and the limit points.
no.
Or
I think you're already starting to talk about metric space. I'm just talking topological space. So you have a collection of sets. You need to know that. You have to know it because nothing else is going to happen after that. So you have a collection of sets. Okay, the empty sets in there. The union of all the sets
so
is in there.
Is it a power set then?
No, it's not a power set.
So,
No.
But it's like so the union of the family of the sets that
Yep.
is in there.
The arbitrary union.
Okay.
So if you like, let's say your set was the letters A, B, C.
Okay.
So well, you have it's a collection of sets. It's not a collection of. Are you going up?
Yeah.
So you have set A, set B, set C, right? So to be a topology, A would have to be there, B would have to be there, C would have to be there.
Right.
A union B would have to be there, A union C would have to be there, C union B would have to be there. The empty set would have to be there,
Right.
okay? And then all intersections would have to be there. A intersect B, A intersects C, B intersects C. So, I mean I haven't touched topology in probably 15 years, and I still remember the definition. You want to get to the point where you understand that definition, because everything's built off of that. Come by my office sometime. I've got my Munkers book. I'll let you look at it.
Okay,
Because you can probably find a copy of it somewhere.
When is your office hours? Or like when are you at your office?
Monday, Wednesday, from, what's today, Wednesday?
Yeah.
From about 1 to 3.
1 to 3.
And then Tuesday, Thursday from 9:15 to like 1.
Okay.
But I will say that today and tomorrow, office hours are cut short because I've got something going on. But maybe next week we can
Yeah,
get together.
I'll probably try to swing by on Tuesdays, Thursdays because I have work and
Yeah.
all that on Monday,
Okay,
Wednesday.
cool. All right, talk to you later. Right, we're here. I didn't stop recording. Oh well.
I was just saying that. I was like, oh, still has his microphone on.
Yeah. I didn't say anything bad. I don't think I did.
You would think after like way feel nice and cold.
Oh no.
You got a freaking improvement.
Okay, so okay, back to this. Okay, so let me just try and kind of, so we don't get too confused here. We start out with this, right? Equivalence. And I told you that it could be rewritten these two ways, right? This will be very useful when we start doing conversions. Like how do you convert 12 feet per second to miles per hour? We're going to use something like this. Now for this problem, what we'll do is we look at what we're trying to find, calories, we put that on top, and then the other part, we put it on the bottom. Then put an equal sign. Okay, I think this will be the easiest way to go through this. Equal sign here, and then now we get to choose from these two. So we don't get to choose, we have to pick one of them, and it can only be one, and it's the one that has the same proportion, calories over bottles. So this one right here, okay, is the one we're gonna pick, all right? Because the same ratio. So I put over here 260 calories over one bottle. And now we're gonna do kind of like a cross multiply. We're going to multiply one bottle times calories here, X calories, and multiply this times this. So at the end of the day, 1 times X should just give you X on the left, and on the right, you get the 260 times 3.5, which is what we said we were going to do from the very beginning, right? Multiply 260 times 3.5. Okay, so what is 260 times 3.5?
910.
910 even? Okay. 910, but we need to remember what we were looking for, right? So calories. 910 calories. Let's do the part B. What did I have for part B? How many servings for 1,000 calories? All right, so this time we are solving for the number of servings or the bottles, right? And so we want that on top, so I'm going to rewrite a new proportion here. We have X bottles or servings over what? We're using this information here. 1,000 calories equals, and now which of the two do we pick here? The bottle over calories. So we pick this one right here. So we put one bottle over 260 calories. And then we cross multiply again. So when that's why I don't like using the word cross multiply, but do we really need to cross multiply? Like, what are we trying to solve for? This, right? Right? That? Do you agree? So all I'd need is that 1,000 calories to be gone. So if I multiply here to here, that's going to get the 1,000 out of here. Does that make sense? And then whatever that is, 1,000 divided by 260 would be my answer. If we cross, then we're going to wind up having to divide the 260 again anyway. So I like to look at this as really like you're multiplying both sides by 1,000 calories. 1,000 calories here. It goes away here, and you wind up with, X equals, and then you do 1,000 divided by 260. Does that make sense or no? Do y'all want to just cross multiply? Does that make your life easier? Okay, I'll cross multiply. All right, what would happen if I cross multiply? Here to here, what would I get? 260x. And then over here, what would you get? 1,000. Okay, now, what are you going to have to do to solve for x? Divide by 260. Do you see, like, by cross multiplying, you added an additional step of then having to divide through. But if you understand it better that way, we can do that. So divide through by 260, and you get 0.38, so 0. Wait, no, I did that wrong, didn't I? Oops. What is it, 3.8? 3.84. 846. 3.846 what? Bottles or servings? 3.846. You could go 3.85. You could go 3.9. Yeah, that's fine. I'm not real particular about the rounding in this class. You're not building a bridge, right? Airplane, not trying to land a man on the moon, okay? So we're all right, so anytime we're asked to look at a problem where we can set up some sort of equivalence, then we're going to create a proportion and then use one of the two proportions that we get from the equivalence to solve for what we're trying to solve for. So take a look at the next one. A leaking pipe can lose 24.7 gallons of water in a week. How many gallons are lost in 30 days? So how many gallons are lost in 30 days? So what are we looking for? The number of gallons that are lost in what? 30 days. So I'm going to create gallons. That's what I want to solve for. X gallons, right? Over what? 30 days. Okay, now I need to come up with some sort of fraction I'm going to use over here to do like a cross multiply. But I need the equivalence. What's the equivalence that I get from this? A leaking pipe can lose 24.7 gallons in 1 week. Yes?
Can we do like 24.7 and 7?
Gallons. Maybe, yes. 24.7 gallons equals 1 week, right? 1 week. I hear it. I hear you. Okay, so from this I can create two different fractions. I can create 24.7 gallons over 1 week, or I can put 1 week over 24.7 gallons. Yes? I can do one or the other. But there's a problem, and I heard someone say it. And what's that problem? Yeah, over here we're talking about days, and over here we're talking about weeks. So what we need to do is turn this into days or turn that into weeks. And I think it's easier to turn this into days. Yes? Yep.
Can we do it the way like it's divided by 7?
Is that what you had said?
Yeah.
Okay, I heard you say that, but you had already created the fraction, hadn't you? You said over 7 or something like that? Yeah.
Multiply by 3.
Yeah, so this is our equivalence. I change 1 week to 7 days. Now that gives me the possibility of two different fractions. I can do this many gallons over 7 days, or I can do 7 days over 24.7 gallons. And again, I can't reiterate this enough. I'm not doing this to try and confuse you. I'm doing this to try and help you when we get to conversions, all right? This is going to be hopefully useful to you. This idea of being able to create two fractions out of one equivalence relationship. Okay, so over here, we're going to use this one, right? Because it has gallons on top and days on the bottom. And so we put 24.7 gallons over 7 days. And y'all like the cross multiply apparently, yes? So y'all just, no matter what, we're just going to cross every time. That's okay. We can do it. Okay, so 7 times x equals 30 times this. 24.7. And then what are you going to wind up doing after you figure out this? Divide by 7. So at the end of this, you're going to be really doing 30 over 24.7 and then dividing that by 7. And does someone have that approximately? Thirty times 24.7 divided by 7. 105.8, something like that. 105.9. Yeah, we can round again. We're not going to get too worried about this. Gallons, right? So if you lose 24.7 gallons of water in 1 week, does it make sense that we would lose 100 gallons, 105 gallons in 30 days? Seem reasonable? Okay. Any questions? Let's look at applications of percents. So this one is, I always am very interested in my students' responses to this. So when you go buy something at the store, a lot of times you have to pay tax, right? Some things we don't pay tax on. Does anyone know an example of something we don't pay tax on? Certain foods, right? Certain foods. Not, I don't think it's everything, but you know, when you go to like H-E-B and stuff, some things are taxed, some things aren't. But not everything is taxed. But if you go buy a shirt at the store, or you go buy a backpack or a calculator or something, you're going to pay tax on it, right? So when we want to find the total amount that we're ever going to pay for something, it's always going to be the price plus the price times the tax. Okay, so that's our kind of formula for it. So if we write this a different way, we could say total equals price plus price times R, where R is the tax rate as a decimal. That's very important, is that when you use this formula, you have to make sure that the tax rate that you put in there has been converted to a decimal. So if the tax is 8%, you have to convert it to 0.08. So what we're doing is we're saying, hey, we're going to pay however much it is, right? And then this right here is like saying what is 8% of the price. So that's going to give you the additional amount with tax. And you add them together, and that's your total. All right? Okay. So let's act like we go out to eat. All right? Let's go out to eat, and let's see how much our bill is going to be. All right? So you buy. You take some of your friends out, right? And you treat them to lunch. You go to lunch. Let's say you go to a lunch where you sit down, right? You have a server. Someone's going to wait on you, right? Bring you your drinks, clear your table, whatever, all that stuff. You go to lunch. Food costs. Food cost is, let's say, $48.64. That's just the food. Okay, that's like the price off the menu. So let's try and figure out how much we're going to pay. Okay, so how much will the total be? So you probably have some questions. Do you have some questions for me? What's the tax rate, right? So is the tax rate on food the same as the tax rate on buying a laptop? Like food at a restaurant? Yep, it's the same. Does anyone know the tax rate? In Texas, 8.25? I think it is. Do we need to look it up? You think it is? Let's just go with 8.25, all right? So we know that, I'm not sure if that's Texas or San Antonio, because it does go all the way down to the city level too. So let's just go with 8.25, okay? Let's just say this is our tax rate. All right. Is that all you need to know? What's that?
The tax rate is
6.25 for what?
state.
Okay, but then we have to add the, no, the like city, because like if you go buy something at like let's say Best Buy, you're not going to pay 6.25% tax. It's definitely over 8%. Yeah, like if you buy a car, then I think your tax rate is going to be about 6%. But all right, so I heard it though. What? Huh? What? Are we tipping 20%? Okay, so tip. We need to take this into consideration. This is why I'm always so interested. Tip, 20%. Do you wait tables? Have you waited tables before? No? 20%? Okay. How do we feel about tipping? Are we all going to tip? Yeah. They waited on, okay, we're going to tip. Anyone not tipping? Okay, good. All right. How many of you are in favor of the 20%? Who thinks we need to be down at 15? My class last semester, everyone was like, 15, man. 15, what's this? Okay, so, all right. I think 20% is probably par for the course nowadays. If you're still living in that mindset that it's 15, like there's something called inflation and it's harder for everyone to make a living. So I think let's go with 20%. So So you know what I have a problem with, and you're probably running into this also, is that now everyone wants a tip, right? Like you go to like, I forget, I'm not gonna call anyone out, but I went to like a sandwich shop the other day, and I'm getting my sub, right? And I'm sitting there, I was like, you know, they put that in front of you, like, do you want a tip? I'm like, you get paid hourly, like you get at least minimum wage, right? The waiters don't get minimum wage. Do y'all know that? They don't get minimum wage. They get some ridiculous, like, I don't know, 2, 4, 3, something like that. So they are depending on your tips to make money, right? And the person behind the counter at the sub shop, they get at least minimum wage, and you're gonna tip them on top of that? So, and then it's always like 15, 20%, you know, like, come on, I'll tip you 5% maybe, you know? I don't know, I'm speaking my opinion here. I just don't think we should tip people who are getting paid at least minimum wage. Okay. Disagree if you'd like. If you're one of those sandwich people, I'm sorry. But have you noticed it, or is it just me? It's like, seems like everywhere I go, there's like a little, like, when you put your card in, it's always like add tip. And I always feel bad because they're right in front of you, you know, like watching you. Like I always feel bad, like, no, sorry. Okay, so we have to take in consideration the tax rate and the tip. The other thing to consider is, are we tipping on this? Like, do you tip 20% on this, or do you tip 20% on this after tax? That is up to you, all right? There's no like written rule like you must tip 20% on this, but normally, like if you've ever waited tables, if you have a big party, they'll have the tip automatically calculated. Like if your party is over a certain amount, that 20%